Welcome to this video on callbacks and higher order functions. These are core principles of the functional programming paradigm in JavaScript. These functions like map, filter, reduce are used every day in professional development environments. And what we're going to do in this talk is we're going to go deep in understanding how to build those functions out from scratch, in order that we develop an intuition of how they work such that we can write them better, debug them better, and deploy them better in our own professional development careers. I recommend you take a look at our first video on the principles of JavaScript, the execution context, the memory, the global variable environment, the call stack, in order to be sure that you have those foundations down, because we're going to be making use of that understanding in this video. But then come join us here and we'll get started on callbacks and higher order functions. We're going to begin with a metaphor. I hate metaphors, but we're going to begin with, no, I'm borderline, I'm very impartial, agnostic, no, ambivalent on metaphors. But here is one that we are going to examine. A function that is going to seem so useless that we're going to realize why we have functions at all, and then why we might have these grand higher order functions, so profound higher order, of a greater order than regular functions. We're going to see why we have them. We're going to see why we have them very soon. But first, we're going to create a function, 10 squared. It's going to feel incredibly useful, I'm certain of it. Lewis, talk me through the syntax, or once the wording, not even declare, talk me through the exact wording of this function, 10 squared.
We're going to define a function called 10 squared.
Okay.
It's no parameter.
Perfect, I'm just going to write this up.
It's going to return 10 times 10.
Okay, function 10 squared. No parameters, no inputs, exactly. In the body of the function, it will return 10 by 10. Okay, Lewis, is this a useful function?
Not at all.
It's a profoundly useless function. At least he owned it. It's a profoundly useless function. I call it, and it returns 100. It literally, there is no variability in what it can do. I can't reuse it in some other way. I can't call it and return 80 or 81, probably a better example. I can't reuse it in any other way. It just evaluates 100, so why not just give the number 100? Well, if you like this function, you love my next function. See? Tell me how to create a function 9 squared. How do I create a function 9 squared?
Declare a function called 9 squared and then return 9 times 9.
Okay, very good, see? Excellent. Skylar, create me a function 105 squared. This is more hard, this is more challenging.
So you declare a variable, you pass it an arrow function.
No, okay, this is not. Skylar, give me a simple function, 105 squared.
Declare a function 105 squared, no parameters, in the body you return out
105 by 105. Okay. These are not useful functions. These are not useful functions, right? A function 9 squared returns 81, 8 squared, 64, 105 squared. Who knows? We have a problem. We're building brand new functions for every single number, every single piece of data. But every one of these functions has something in common. What can we do? Just to multiply me by myself bit. Like I'm multiplying some number by myself, and every single function has that in common. And yet I'm building an entire new function for each number, 9 squared, 8 squared, 100 squared. Is there something we could do differently here? Lewis?
You can add a second parameter that takes...
A second parameter?
Yes.
There's no parameters. Just any parameter?
Well, any parameter.
Yeah, you can add any parameter.
You could generalize it.
You could generalize a function by, as Lewis says, adding a parameter. We could generalize our function and create something square num, and then leave a blank num for later. When we call square num, fill that blank in with an actual value, 10, 9, 8, 105, whatever. We can say square num is our general definition of how this functionality will work, where it's taking some input and multiplying it by itself, and then don't determine the specific number we're applying that functionality to until we call, until we invoke, until we run that functionality, and leave it generic, leave it general when we define it. So we can reuse it as many times as possible. For 10, to make it live, 10 squared. 9, to make it live, 9 squared. 8, make it live, 8 squared. And this principle of making our functions reusable so that I can take the functionality, multiply it by myself and reuse it again and again for different numbers, for different data, that principle is going to turn out to be the essence, analogously, of why we have our higher order functions. It may turn out there's not just some data we don't want to determine until we run the function, some number, but actually there may even be some functionality we don't want to determine, we don't want to be specific on until we end up running the function. It's going to start with this function here, copy array and multiply by 2. A function that's going to take in some list of data, 1, 2, 3, 4, 5, 6, 7, whatever, and then it's going to take each of those numbers, having created a brand new empty array, it's going to take each of those numbers, double them, multiply them by 2, double, and push them to that new array. So we end up with a brand new array with each of those input numbers in the input array. We'd get a brand new array with each of those input numbers doubled in that new array. Copy array, and multiply by 2. As I say, this function is very useful. Taking some input data and doing something to it, we do this all the time. But we're going to discover, man, this and future functions are going to feel very repetitive. But we're going to feel in our gut to understand why we have a different approach, a better approach. But here we go, starting off with our code here, copy array and multiply by 2. Let's walk through it line by line, starting off with our friend Lewis. What are we doing in the very first line of code, Lewis?
We're declaring a function called copy array and multiply by 2, and we're storing it in global memory.
Excellent, thank you, Lewis. Copy array and multiply by 2, and the whole function definition, I'm drawing it, remember, as a little box like this. It represents the entire function definition. If I were to console log copy array and multiply by 2, I would see the entire function's description. Function, copy array, multiply by 2, parens, array, whatever it might be, the whole thing, because it's all stored in memory. All right, Z, next line of code.
We're declaring a variable called myArray in the global context.
Okay, myArray is stored in global memory, excellent, with the values 1, 2, 3. Next line, Philip.
We declare a variable result
Result.
in the global memory, and we are going to be setting it to undefined right now until we run the function.
Which function?
Copy array and multiply by 2.
Copy array and multiply by 2. So keep me going, Philip. So I'm going to run copy array and multiply by 2, pass in
myArray,
which is the array 1, 2, 3. Yep, perfect. I'm just going to write it indirectly. And I know the return value, the output, whatever gets returned from this function call, whatever gets returned from it, is going to be stored in what, Philip?
Result.
In result. Perfect. All right, so we're calling a function. How do I know I'm calling a function, Skylar?
Because you have parentheses.
Parentheses, they're the all-powerful symbols in JavaScript. They say, go take my code and run it, and anything that you declare inside is stored in a memory. What's that combined known as? An execution context. Storing stuff in memory and going through the code line by line, bundled up together, is known as an execution context. Here it is. Fantastic. There it is, and into it we go. Now we can also keep track of these execution contexts on our call stack. We may not always do so rigorously, but here it is. We're in global to start with. We started calling copy array and multiply by 2, so we add it to our call stack, our stack of functions being called, being invoked, and we're now inside copy array and multiply by 2. It's top of our call stack. All right, first thing we do inside, Philip.
We declare the parameter myArray.
We declare
Oh,
parameter.
I'm sorry, the array, not my array.
Okay, perfect. Parameter is array.
And we set it equal to the array 1, 2, 3.
Yep, the value of the argument that's my array, which is the value 1, 2, 3. Perfect. Next line, Z.
We declare a local variable called output and we set it equal to an empty array.
Good. Local variable output, there it is. Empty array. Perfect. Excellent, thank you. Very good, Z. Next line, Z.
Next line we run the for loop.
Aha. Okay, so we initialize a for loop. I'm just going to take this array 1, 2, 3. I'm going to put these on the left-hand side, which is slightly contravening our thread, this being our thread of execution. I'm going to use it almost as a workspace to talk about manipulating array rather than doing on the right-hand side here. So when we hit the body of the for loop, I like to think about talking through for loop execution line by line, not I loop through the array and it's kind of vague, but literally I hit the body of this for loop, the 0th time when I is 0, what happens? Tell me, Z.
We push the first element of the array.
Okay, so we take the 0th element when I is 0, so array sub 0, array index 0 is what value?
It's 1.
It is 1.
We multiply it by 2 and that result gets pushed into output.
Perfect, we take the 1, we multiply it by 2, we get 2, and we push that to output. Excellent. Array position 0 is the number 1 because it's from my array which is passed in and filled in. Array position 0 is number 1. Array index 0, array sub 0, always saying the same thing. We grab that 1, multiply it by 2, we get 2, and we push it to output. Perfect. All right, now it's a for loop. So Lewis, what happens next?
Now we're increasing I by 1.
Perfect.
So I is now 1.
Yep.
I is less than the array length. So
Okay.
now the index of 1 is equal to the value of 2. We're
Perfect.
multiplying that by 2 and then pushing it to our output array.
Very good. So we get the number 4, which we push the output array. It's a for loop, so we're going to do it again, get 6. For loop's now finished. All right? Because at this point, when I is 2, we grab my array position 2, which is 3, we multiply it by 2, we get 6. We increment I one more time to 3. Now is 3 less than the length of the array 3? No, it's not, it's the same. And so we skip out of the for loop and hit the final line of the function, Lewis, which says what?
We're returning the array containing 2, 4, 6.
Absolutely, the value of output. Return output, value 2, 4, 6. Return it out into what global variable?
Into global memory, the variable result.
Perfect. And we know to go back to global because we hit the return statement of our function, copy array multiplied by 2, meaning it got popped off the call stack. The call to that function was ended, and look, where do we go back to but to global. All right, where we returned out the 246 and stored it in the global variable result. And our goal of input 1, 2, 3 array, returning out from copy array and multiply to a brand new array containing those input values doubled, 2, 4, 6, we have been successful. Okay, let's have thumbs on this core function. You lost me, I am clear. I have some clarification questions. Everyone's thumbs out. Everyone's thumbs are up. No clarification questions. All right, fair enough. Well, if you like this function, you will love my next function. This next beautiful function, very nice function. Copy array multiply by 2. This next function is very different function. Copy array and divide by 2. Look at this, radically different. We're going to go through it though to feel just how different it is. And there may be more that look just like this. We're going to feel this pain because with this comes an understanding of why there might be a better way. So here we go. Copy array, and this time we're going to divide each element by 2. Not multiply each element by 2, but divide each element by 2. Line 1, I'm not even going to write it out again. I'm just going to erase the bits that change. just so we know just how little it is changing. So line 1, Z, what are we doing?
We are declaring a new function called copy array and divide by 2.
Excellent. Correct. Copy array and divide by 2. Excellent. Next line, Z.
We're declaring the global variable my array and setting it equal to an array of element 1, 2, 3.
Very good. Very nice, Z. Next line.
And then we declare a global variable result.
Yep.
And we're setting it to undefined until we invoke the function.
Okay, so off we go and invoke the function. Copy array and divide by 2. Invoke with the parens, that means run the function. What do we do at that point, Z?
We create a new local context.
New execution context, there it is.
Context. And we set the parameter array to 1, 2, 3.
Perfect. We set output to
Empty array.
empty array. And now we hit the body of the for loop, where we grab Philip. When we first hit the body of the for loop, what is the value of I?
0.
I is 0. So array sub 0, array index 0 is what?
1.
1. So we take that 1 and do what with it?
Divided by 2.
And get
0.5.
0.5.
Oh, 1. Wait.
No, 1 divided. No, you're spot on. No, you're spot on. 0.5 is the British word for 0.
I was like, what?
Half. 0.5. I can tell you a funny story, which I will not tell on video, of the confusion that 0 and 0 can cause. Good. Anyway, there we go. 0.5. And what do we do with that 0.5, Philip?
We push it to our output variable.
Perfect. Into output array. All right. Okay, but it's a for loop. It's a for loop, so we're not done yet. We hit the body of it again. This time the value of I is what, Skylar?
Is 1,
Is 1.
which points to the value 2.
Okay, is 1, which is array position 1 is 2. We take that 2.
Then divided by 2.
And get
1.
1.
Push that to our output array.
Perfect. It's a for loop, so we get the next one, we get 1.5. There we go, 0.5, 1.5. And now we hit the close of our function, the final line, Lewis, which says what?
We're returning the output, which is the array containing 0.5 divided by 1.5.
Into
Our global memory, which is the result.
the result global variable. And look at that. We have successfully run copy array and divide by 2, which took in 1, 2, 3, and returned out 0.5, 1, and 1.5. This combination, this function has served its purpose. It has taken in an array and turned out a brand new array with each of those input elements in the input array halved. Okay, we like this function. Imagine if there were another function. Imagine there were another function. This function, very different to copy array, multiply by 2, copy array, divide by 2. We're in copy array and add 3. Copy array and add 3. We're going to build a brand new function for it. No, we're not. All right. What principle are we breaking, Z? What principle are we breaking by building out each of these functions?
Do not repeat.
Yeah, dry principle, right? Don't repeat yourself. We're breaking it profoundly. Everything's the same. Copy array and multiply by 2. Take in an array, create a new output array, loop through the input array, take each element, do something to it. The only thing that changes is what is the only thing that changes, Lewis?
The functionality that you're doing to the element.
To the individual element. The operator and the operand, the individual thing, the functionality we do to the individual element. And yet we're building out entire new functions, copy array and multiply by 2, copy array and divide by 2, copy array and add 3. We're building all that functionality, but the only thing that's changing is a little thing we're doing to the individual element. Philip, can you think of a better way of doing this? Can you think of a different, if we think back to our function 10 squared, 9 squared, 8 squared, 105 squared, is there a better way you can see of, rather than building out brand new function, what could we do?
Sure, we could generalize it more.
We could generalize it. How would I do that? You say to make it reusable, but how? Because I can't just go about like passing. Well, give me more details.
Give it another parameter.
Another parameter. So you're saying build one general function. We could call it copy, array, and manipulate, and then leave a placeholder parameter for when we run that function. Fill that place or that parameter in with the specific functionality +3. Divide by 2, multiply by 2 that we want to have applied to each element. Okay, but how would we pass that in? Could we just pass in? +3 like that to apply it inside? Is that legit?
No, we can't do that.
We can't. So we can't. So we could imagine a language we could, but in JavaScript we definitely can't just pass little bits of functionality around and leave placeholders. It'd be lovely to leave a placeholder and pass in the +3 when we run copy array and do something, manipulate, let's say. But we can't do that. How do we wrap up functionalities we pass around in JavaScript, Z?
In a callback?
More intuitively.
In a function.
It's in a function, yeah, as you rightly say, Z, like in a function. The only way I can pass functionality around in JavaScript would be to get rid of the +3 and actually pass in, leave a placeholder for some functionality represented as a function. And that's what we're going to do. That is exactly what we're going to do. We can generalize our function that we pass in a specific instruction only when we run the copy array and manipulate. So we can build a brand new function called copy array and manipulate, and when we call that function, when we run that function, when we invoke that function, at that point we can pass in the specific functionality. But we're going to represent that with these instructions. So just like array becomes 1, 2, 3 when we run copy array and manipulate, so too instructions is going to become multiply by 2. We're going to end up with multiply by 2, grabbing the individual element of the array as an input to multiply by 2, taking the array position 0, which is 1, and throwing it into multiply by 2 and returning out 2, achieving the same as when we had array position 0, number 1, multiplied by 2. We can't pass in multiply by 2. All we can do is pass in some functionality and then have the array position 0, the number 1, thrown in to that functionality and then returned out. We sort of flip it on its head. So we're going to leave a placeholder so that we can just have one copy array and manipulate function and then have a placeholder not only for our data to be filled in with actual data 1, 2, 3, but also for some of our functionality. We're going to have some of our functionality, in this case, the thing we do to the individual element, also left unknown, left blank, until we run copy, array, and manipulate. And at that point, we'll figure out what's instruction's going to be. We'll figure out what's going to be. All right, we're going to walk through this very precisely line by line so we truly understand it. This is the last of our callback and higher order function code. Here we go. So, line 1. Skylar, what are we doing in line 1?
So we're declaring a function copy array manipulate with the parameters array and instructions.
Copy array and manipulate. Copy array and manipulate is a whole function definition stored in memory. But we're not done yet. Z, what's our next line of code say to do?
We declare the function multiply by 2 and store in global memory.
Multiply by 2, and it's a little baby function, little tiny function. Only going to take in a single element, hopefully. I'm going to multiply that by 2. So we have a big function, copy array manipulate, a little baby function multiplied by 2. Excellent. Next line, Lewis.
We're declaring a variable called result,
All right.
setting equal to undefined until we invoke copy array.
Until we get the return. I would say rather than until we invoke, even as we're invoking it, it's going to be undefined until we get the return value from the call to copy array and manipulate. Copy array and manipulate, and this function is taking in what as its first argument, Lewis?
First argument is an array containing 1, 2, 3.
Okay, perfect. And the second argument, Lewis, is?
is the function definition multiplied by 2.
Aha. The whole function definition of multiply by 2. Huh. So it's the whole function, we're grabbing the whole thing. So just like inside this copy array and manipulate, array is going to be replaced by 1, 2, 3. Wherever you see array inside the body of this function, no longer. It is going to say 1, 2, 3. JavaScript is going to replace it, pull it out, and replace it with 1, 2, 3. Similarly, wherever you see the word instructions inside of there, JavaScript is going to grab out those instruction placeholder and say, it's going to replace the whole word instructions with the words multiply by 2, because 1, 2, 3 is filled in array and multiply by 2 is filled in instructions. And so wherever you see instructions inside of this function, it's going to be switched out for multiply by 2, meaning we're going to see something like multiply by 2, parens, multiply by 2 being run with the input of array position 0, 1, multiply by 2, input 1. We're going to get there in a second. Okay, so we're calling a function, copy array and manipulate. We know its output is going to be stored in the global variable result, but we've now got to execute this function. So everyone together, we create a new
Execution context.
Okay, that was very in sync, very good. Excellent. All right, new execution context, very important thing to remember. And say in chorus. Good, so into it we go. And it has a local memory, and our thread wends its way in. Okay, into the local memory, we will be storing first our parameters and arguments, or parameters with their associated value of the arguments. So Z, what's the first thing that goes in the local memory?
The first parameter is array, it declares array.
Yeah.
And it's going to be the array 1, 2, 3.
Perfect. All right, and the next one, Philip?
It's going to be instructions. And it's going to be set to the value of multiply by 2.
Perfect. The function definition of multiply, with the previously had the name multiply by 2, it's just the function definition. This whole function definition, previously known as multiply by 2, not inside of here. It was known as multiply by 2 inside of here. Now we're going to refer to it as instructions. So to be clear, Philip, if I wanted to run the functionality formerly known as multiply by 2 from out here inside a copy array manipulate, what label could I use for it?
I would use instructions.
Instructions, and I know, and so if I wanted to run multiply by 2 with the input of 3, what would I write?
Instructions parens 3.
Because this really is multiply by 2. It's going to be switched out for JavaScript in its mind and switched with multiply by 2, with parens on the end. Okay, perfect. All right. Next line of code, Lewis.
We're declaring a variable output, setting it equal to an empty array.
Perfect. Empty array output. So we have output's empty array. Array is 1, 2, 3. And now we hit the all-important moment, the body of the for loop. Okay. I has the value of what the 0th time we hit the body of the for loop. I has a value of what, Skylar?
0.
0, perfect. So I has a value of 0, so array index 0 is what, Philip?
1.
1. So we take that 1. Array index 0 is going to be switched out for the value 1. What is instructions being switched out for the value of, Philip?
Multiply by 2.
So we've now got multiply by 2, parens 1. So we've got to create what, Philip? A new
Execution context.
A new execution context for instructions, really multiply by 2 with the input of 1. And we've got to create a new execution context for it. Oh, and we need to keep track of these on our call stack. So there's our copy array and manipulate. We were currently in that, but within that copy array and manipulate, we're going to call instructions. So it gets put on the very top of the call stack. Instructions with the input of 1, and that's where we are at the moment. That's where we are at the moment. Okay, and into it we go. And what we're really doing with run instructions is running multiply by 2, so our input of 1 is being thrown into instructions, really multiply by 2. So what, Lewis, is the first thing in our local memory of this instructions really just multiply by 2?
So our parameter input is going to be 1.
Perfect. Input, so we look to multiply by 2 and see what is that 1 being thrown in to replace? Input. So we get input is 1. And then, Lewis?
And then we're going to return input times 2, which is 1 times 2, which is 2. And that's going to be returned to the execution context of copy, array, and manipulate.
Perfect. Return one layer out to the execution context of copy, array, and manipulate. That is to say, multiply by 2, input of 1. That whole little section of code is going to be switched out and replaced with the return value of running multiply by 2 with the input of 1, which is 2. And so this whole portion here will be replaced by 2, the return value. And that 2 gets pushed to the output array. Okay, and this execution context, Skylar, what happens to it?
It goes away.
It goes away, we pop it off, but it's a for loop, and so we go back inside the for loop, and this time the value of I is what, Philip?
1.
So array index 1 is what?
2.
And we do what with that 2?
We pass that to instructions, we pass that to instructions.
Which is really?
Multiply by 2.
Okay, so we create a new,
Execution context.
we pop off the last one, we forgot to pop it off, but we quickly add back on another one, instructions with 2, in we go, and what's the first thing, Philip, in our local memory?
Our parameter input is set to 2.
2, perfect. We do 2 by 2, which evaluates a 4. We return out that 4, which is the output of running instructions with the input of 2. We return out that 4 and store it, push it to where, Philip?
The output array.
Perfect. So our instructions really multiply by 2. Input 2, which is array at position now 1, which is the number 2. 2 goes in to multiply by 2. Instructions really multiply by 2. And that multiply by 2 input of 2 returns out 4. And that 4, that whole block, the running of instructions, the calling of it with the parens, which is really multiply by 2 being run, the whole thing gets switched out with a return value, which is a number 4. And that 4 gets pushed to output. But it's a for loop. No, I'm not going to do it again. There you go, 6. 2, 4, 6. And now we hit the final line of the function Z. What's the final line of the function here to do?
Return output.
Return the value of output, which is 246, into the global variable result. There it is, 2, 4, 6. And we have achieved the exact thing we did with our copy array and multiply by 2. We've achieved the exact same thing, but we create a brand new function called copy array and manipulate. And then we left blank what exactly we were going to do to each individual element. We left a placeholder for the specific instructions we were going to do. And copy array and manipulate, when we passed in 1, 2, 3 and the specific instruction multiplied by 2, kind of live dynamically became copy array and multiply by 2. So we took in 1, 2, 3 and returned out 2, 4, 6. We achieved the same thing as copy array and multiply by 2, but we never specified in copy array and manipulate this will do multiply each element by 2. We left it blank what was going to happen to each individual element. We left a placeholder for it, and then threw in, only when we ran copy array and manipulate, the specific instructions we're going to apply to each individual element. So, how is this possible? If you come from a language other than JavaScript, the notion of passing in a little baby function into another function to be used inside that function is anathema to your standards, to what you know of language design, what you know of how functions should work. And yet here, totally fine. Totally fine for us to pass a function in as an input to be used inside of copy array and manipulate. We passed in a little multiply by 2 to be used under a new label instructions. It allowed us to make our function general. because we could leave it blank, leave it unspecified what instructions there's going to be, what's going to happen to each individual element, and then fill it in only when we run copy array manipulate. How is this possible? In JavaScript, functions are what's called first-class objects. That means they have all the properties of objects, and not they sort of have they are absolutely objects. They have one bonus property we'll see in a second, but otherwise they are absolutely just objects. And we know we can pass objects in to functions, no problem, perfectly standard. But we can also pass, therefore, functions that are just objects into functions. They can coexist with and be treated like any JavaScript object. They can be stored on variables. That's why you see var multiplied by 2 equals and the definition of the function. They can be stored as properties of other objects, where they're known as methods. They can be passed as arguments, inputs into functions. And they can be returned as the return value. Here we returned an array, which by the way in JavaScript is also an object, but they can be returned as the return value. The function can be returned out as a return value from another function. And we'll see soon that gives us the most beautiful concept in JavaScript known as closure. Functions have one special property that objects don't have. Philip, what's the one thing they can have?
They can be invoked.
They can be invoked. You can put parens. I can't declare an object and then invoke it, but functions, despite being objects, have the ability to be invoked, to be called, to be run. And we're going to see that has consequences later on in our object-oriented programming, all to come. But for now, here's our question. This most profound concept, callbacks and higher order functions. I remember when I first encountered it, functions of a higher order. This most profound concept, we've seen it all. We've seen everything there is to see. So, which of these then is our higher order function and which is our callback function? One of these is our higher order function, one is our callback function. Skylar, which would you say is our higher order function?
Multiplied by 2, because you're passing it in.
Philip?
Copy array and manipulate.
Copy array and manipulate is our higher order function. And then the little baby function that gets passed in, that's our callback function. Our higher order function is the outer function that takes in a function, or by the way, any function that returns out, any function that takes in or returns out a function, that host function is our higher order function. It's of a higher order, it can handle other functions being passed in and returned out. And then the function we pass in, multiplied by 2, its placeholder was instructions, but multiplied by 2 is a function, that's our callback function. So, callbacks and higher order functions, they simplify our code, they keep it dry. We no longer had to create copy array and add 3, copy array and multiply by 2, copy array and divide by 2. We built one general copy array and manipulate, and it had a placeholder for the specific thing we were going to do to the individual elements. And we can pass in, therefore, multiply by 2 as a function, or add 3 as a function, or divide by 2 as a function. We can pass those in, allowing us to have one general function, because I think all the code was the same. If you look back to copy array and multiply by 2, copy array and divide by 2, copy array and add 3, all the function code was the same. We had take an array, create a new empty array called output, loop through the input array, do something to each element, return out the full new output array, but all that code was the same. The only thing that changed was what did we do to each element. So leave a placeholder for that, and then pass in that specific instruction to do to each element only when we call copy array and manipulate. Pass in the specific functionality to do with the individual element multiple times in the for loop, only when we run copy array and manipulate. Pass in that specific functionality known as our callback function. So, Callbacks and higher order functions simplify our code. They keep it dry. Don't repeat yourself. And they do something even more powerful that we're going to see later on. They let us run asynchronous code. And all that is to come later on.